Systems of equations are helpful for a whole bunch of reasons. Today, we're going to talk about one application of a system of equations, and this is something that's really common, especially in the algebra classes, and it's figuring out how old two different people are based on almost a sort of riddle that they give you. So let's look at this one. We've got Jenny. She is 5 years younger than Jill. If you add their ages, the sum of their ages is 31. How old is each person? So first thing I'm going to do is I'm just going to make some notes. I know that Jenny equals, she's 5 years younger than Jill. So that means whatever Jill's age is, if I subtract 5 from that, I'm going to get Jenny's age. So that's helpful. The sum, this word here, means that we're adding. So now I'm on to my second relationship between the two of them, and that relationship is adding. So I'm going to add their ages. So Jenny plus Jill is going to equal 31. And then they want me to figure out, using just these two pieces of information, how old each person is. So to do this, let me go ahead and rewrite these using some sort of variable instead of Jenny and Jill. It'll just make it easier to work with. So maybe over here to the right, I'll label Jenny as X and Jill as Y. Then my two equations become Jenny equals Jill minus 5, and Jenny plus Jill is 31. And this might look a little bit more familiar if you've been working on solving systems of equations. This one's set up super nicely for substitution. I know exactly what x equals. It is y minus 5. It's not our favorite. We'd rather them just tell us what x is, but we still know what x is in terms of y. So I can take that x and put it into x in the other equation. So now this second equation, instead of x plus y, I'm going to replace that x with my y minus 5. So this is still x plus y, but the x is just rewritten in a different form. And the reason this is helpful is because now I have all y's and I can solve. There is no coefficient that I need to distribute in front of the parentheses. There's no exponent holding everything together. So those parentheses I can just erase. And then I can combine like terms. I've got y plus y is 2y, and then this minus 5, and then I just solve. So I found my y, but let me go back and use that to figure out my x. You can plug it into any equation that has both x and y in it, but I'm going to plug it into the one that I feel is like the most straightforward. So that would be this first one, where they tell me what x equals. So when I plug in the y, I'm not going to have a whole lot of work to do. So I'm going to take this equation, x equals y, I know what y is, it's 18, minus 5, so x is 13. We could check this. Jenny is 5 years younger than Jill, so when I look at these two, one is 5 less than the other. And when I add them, we get 31, and sure enough, 13 plus 18 is 31. So to answer the question, we go back to our original statements up here where we labeled our variables. Jenny is x and Jill is y. So Jenny is x, which is 13 years old, and Jill is 18. And that would be the answer to our question. Thanks so much for watching, and I will see you next time. Bye.